on your screen is a mirror. It has this plane and smooth reflecting surface on one side. It's called a plane mirror because its reflecting surface is flat. What other types of mirrors have you seen? Have you seen this type of mirror? Well, you must have seen it on the stand of your bathroom or maybe hung up there on a wall. This is not a plane mirror. Try to move your hands over the surface and you will notice it. This is called spherical mirror, or more precisely, spherical concave mirror. It is curved inwards. It is kept there as we use it mostly when we are shaving. Now the obvious question that must be coming to your mind is, why do we use concave mirror for shaving instead of a plane mirror? For the answer to this question, you have to wait for our future videos. For now, we will be concentrating on the plane mirror only. So let's consider this plane mirror again. When we stand in front of a mirror, we see an image of ourselves in the mirror. Nothing surprising there. Why are we able to see our image? Yes, it's due to the reflection of light. In fact, it's due to multiple reflections of light rays. How? The light rays from the source are first incident on our body. They bounce off from our body and fall on the surface of the mirror and again gets reflected from there. This reflected light then reaches our eyes and we see our image. So what does this tell us? Yes, this tells us that a light ray can get reflected multiple times. The same thing happens for every other non-luminous object as well. If you remember, my initial goal was to explain what virtual and real images are. Let me ask you a question. This image that you see here, is it a real image or a virtual one? This image is a virtual image. In order to explain what a virtual image is, let's first simplify this image. Let's represent this boy with an arrow pointing up. And here is our plane mirror. You can assume the top of the arrow to be the top of the head of a boy. Now, where is the image of the boy formed? When we see the image in the mirror, it seems to us that the image is formed somewhere behind the mirror. But there is nothing behind the mirror, right? For us, the light rays seem to come from the location present behind the mirror. For instance, consider a few light rays emerging from top of the arrow. All these rays are incident on the mirror and get reflected back. Yes, all the reflected rays will follow the laws of reflection. You see that all the reflected rays are moving away from each other, that is, they are diverging. But we know that the image is formed somewhere behind the mirror. So let me extend these reflected rays backwards and see what happens. We see that they meet at this point behind the mirror. And to us, this is where the top of the image appears to be. When we look at this point, it appears to us that all the light rays are diverging from this point. But in reality, there are no light rays behind the mirror. This being a smooth and shiny surface reflects most of the light back and almost no light reaches behind. But yet, we have the perception that the light rays are coming from the point behind. So we just consider the top of the arrow here. We can do something similar for the remaining points on the object to get the complete image. So we say that the image formed here is virtual, or in other words, not real. You can think of a virtual image as an image which appears to be formed in a position somewhere behind the mirror. But in reality, it isn't there. A virtual image is formed when the light rays diverge after reflection from the mirror. Every plane mirror forms a virtual image. This is the first characteristic of the images formed by plane mirrors.